All right, in today's video, we're going to show you how to program and cut out a prismatic letter. For those of you who don't know what a prismatic letter is, I've got a picture here on the screen that is basically showing you. So it's a profiled letter like you would normally cut out on any CNC machine, but what you're doing is using a various degree V-bit on the top to create this prismatic or kind of pyramid look. And depending upon the angle of the V-bit you're using, you'll get either a shallower or a deeper angle on this prismatic look. And they're used commonly in the signage industry. Gives a little bit more depth, a three-dimensional look, as opposed to a regular profiled letter or profiled letter with a radiused corner on it. So as you can see here, there's a couple different letters, and I just think that the look and feel of a prismatic letter is pretty cool. So I've got an application where I've got to cut out some letters here, and I thought I would take this time to do a quick video to show you exactly what needs to be done. So in VCarve, we're going to be using sign foam or urethane foam that's 1.5 inches thick. Now there's a lot more letters that I have to do, but I'm just going to do the demo on this video using one letter, and that'll be a capital B. So I've set my material size to 14 by 14. I could actually go even smaller. I can go 10 by 10 because the letter is only 7.5 inches tall or so. I'm going to set my Z0 to the top of my material, and my XY datum start position is going to be the lower left corner for this. So I'm going to go ahead and click OK. So right now I have a letter that is, let's see, it's 7.45 inches tall by 6.5 inches wide. So what I'm going to do is let's just start by doing a normal profile cut and see how that looks. So we would go over here to the profile toolpath. I'm going to set my start depth as 0 and my cut depth to 1.5 inches. For the purpose of this, I'm just going to use a standard 1/4 inch bit. I've actually got a bit that I'm going to use that has 1.5 inch cut flute on it for this particular, but for the simulation, I've just got a 1/4 inch compression selected. And I'm going to go ahead and cut my machine vectors outside the line. Now, Vectric is smart enough to know that if you select all of your lines here, it's smart enough to know that this outside line of the B has to be cut outside the line, and the inside part of the B has to be cut inside the line. There was a time in the past where you would have to do two separate tool paths. You'd have to make an inside tool path for these and an outside tool path for this. So as long as you select everything and you select outside, then you're good. Everything is going to be all set, and it's going to cut it the way it needs to. So because this letter is only 7.5 inches tall, I'm going to be using a CNC machine with a vacuum table to hold these down. But due to the size of the letter being a little bit on the smaller side, I am going to add some tabs. So I'm going to add some tabs that are 1/2 inch long and 0.3 inches tall, and I'm going to use 3D tabs here. Now a 3D tab is kind of ramps up, like it makes a little pyramid on the bottom. It's going to ramp up to an angle and then back down again. There's a little picture of it here. And the reason I like using a 3D tab is when you're cutting and you've got a 3D tab, let me just draw a line here. So if I got a line, then here's my tab, and then a line again. So when my machine is cutting, it's able to continue cut at speed, and then it continues at speed as it's ramping up and down the tab, and then it goes across. Now if I was doing a regular square tab that looked like this, now what has to happen is my machine has to come to a stop for a split second when it reaches the vertical wall of this tab. Then Z has to go up, it goes over again, Z has to go down, and then it continues. So it's faster to run a 3D tab on your machine. You've got a little less material to use for the tab because you're eliminating this part of the triangle up here than you do with a square tab, but it does run faster. So in order to make sure that my tabs are going to hold well, I just do them 1/2 inch long. So from here to here is going to be 1/2 inch and 0.3 inches tall, and that should be more than fine. And then I'll go ahead and I will cut these off using a multi-tool. So what I'm going to do is let's select everything here again. I've got my tabs. Now I have to edit my tab locations. Now, I don't like putting tabs on radiuses if I can help it, because I'm going to use a multi-tool that has about 1.25 inch straight blade on it. And that means that I'm going to have to go back here and I'm going to have to do some sanding to get that out. So what I like to do is try to put my tabs on straight areas of whatever it is that I'm cutting. So in this case, I'm going to do a tab here, here, and one over here. And that should be enough to hold this in place. Now on the center, I'm going to do the same thing. I'm going to do a tab here and here, and here and here. That way those little infill pieces don't kind of fall out and slam into the blade as I'm cutting. So now I'm going to go back here, and the one last thing I'm going to do is I'm going to add a separate last pass. Now, as you see, because I'm doing 1.5 inches, I'm going to end up doing this in 6 passes. And what that means is that if you look at the side walls of this letter after it's cut, most likely you're going to see lines from each pass as the end mill goes around it. And that's okay, but what we're going to do is we're going to do a separate last pass that is 10 thousandths wide. So what's going to happen is it's going to cut this letter out 10 thousandths larger than it currently is drawn on the first 5 passes. And then when it goes to do the last pass, it's going to move back in 1/10 of an inch, and then it's going to go ahead and do an entire cut all the way around. And what's going to happen is, since my end mill is 1.5 inch cut height on it, it's going to ensure that all those lines are basically erased, because now I'm going to cut the entire thickness of the letter, and I'm going to take that that full 1/10 of an inch off all the way around. So it's going to give, it just means less time that I have to spend sanding and finishing these letters. It's going to come off the machine, you know, pretty much ready to go. So that is pretty much it. I usually add a ramp. I do a smooth ramp at 20 degrees. I just prefer to enter the material at an angle rather than plunging straight down. I'm going to go ahead and click calculate. So if I preview this toolpath, you'll see what we're left with now is, and I can't remove the waste material by clicking on it because it's held in with tabs, but you can see I have letter B here, and the sidewalls are 1.5 inches tall. And, you know, depending on your sign, that could be a really cool look if that's what you're looking for. But we want to take this and make it even cooler. So what we're going to do is go back over to 2D view, and right here on the second row of toolpaths, third from the end, is the Prism carving toolpath. And we're going to click that. Now, what I have in my library quite a few V-bits here. I've got 110 degree, 90 degree, 60 degree, 45 degree, 120, and a 140. Now, I'm going to go ahead and I'm going to use my 140 degree. This is an Amana RC1111 V-bit. And I'm going to go ahead and use that for this particular application. And I'm going to set the depth for full prism. And basically what that means is that in order to get that full pyramid prism effect, Vectric will calculate how deep it has to take that V-bit in order to make that happen. So I'm going to click set depth for full prism, and it's going to automatically calculate this depth. So now I'm going to click calculate, and I see I've got a toolpath here, and I'm going to go ahead and I'm just going to preview that toolpath. Now you can see after this is done, what we're left with is this very cool prismatic look on the letter. All the V-Carve took care of everything. It took care of all the calculations that are needed to get that effect on there. And you could see how it's kind of overcut into the waste material. That's because the bit I'm using is pretty large. It's a 140 degree V-bit that has a diameter of 3.0781. So it's a pretty big diameter. And when you consider, if I were to draw, you know, a V-bit that was had a diameter of 3.0, let's just say 3 inches, you could see from the center of the end mill, that's how much material it's cutting. So it's a pretty large bit. And so it will cut into that waste material, and you just have to plan for that, especially if you're going to lay out multiple letters. You want to make sure that your next letter is far enough away so that this overcut here doesn't cut into your final letter. That's why the preview option of Vectric is like super critical, because it lets you see exactly where the end mill is going to cut and let you know that. Now this particular letter calls for a total height from the bottom to the top of 1 1/4 inches. Now this material is 1 1/2. That's just because we can't get HDU and 1 1/4. So we're going to use this toolpath to get us 1 1/4 at the highest spot of the peak. Now if you look down here on the screen, you can see as I move my mouse around the piece, you'll see right now it says Z0. That's because I set the Z0 for my job at the top surface of this part. But as I move my pointer into the areas that are cut, you could see that that Z goes negative. So for instance, right here, I'm at minus 0.2, so almost a quarter of an inch. From the top surface. So that's how much material I've removed here. So what I'm going to do is I'm going to use this pointer to come over here, and I'm going to put it right at the top ridge of the B here, and I want to see what it says. And right now I'm at 0.0178. So that's telling me that right now my letter is actually pretty close to, it's only 18 thousandths smaller than 1 1/2 inches. So I need to get that reduced a little bit more. So I have a couple options here. I can set my prism depth deeper, so I can go 0.4 on this and recalculate that. I have to reselect my vectors. And let's see what that does. I'll reset my preview, and I'll preview all toolpaths again. And now I can look at this and see if we have any difference here. So now when I go to the peak there, I'm at just under 1/8 of an inch. So I still need to go down a little deeper to get this top height. And what I'm talking about is if you look at the letters from the end here, you see how you've got these kind of, looks like mountain ranges, you got these peaks. The plan for this letter calls for 1 1/4 inches from the bottom to the top of the highest peak. And so I need to make some adjustments to make that happen here. All right, so going from this peak here, I'm just under 1/8 of an inch. One of the things I can try is we could try using a different end mill. But if I like this angle that I've got here with the 140 degree, then my adjustments are going to be in changing the prism depth. So we're going to change it now to 1/2 inch. We'll reset the preview all again, and we'll see if that lowered it at all. It should have lowered it quite a bit. And so now when I touch it, I'm at 0.2162. So I'm pretty darn close to 1/4 of an inch there. I can make one more adjustment probably and go 0.55 and recalculate. And then I'll just preview that prism toolpath, and you can see that's removing more material. So that should get the letter down now to 0.2589. So that's, I'm going to call that really good. So I've got 1 1/2 inch material, and my top point here is at 0.25, minus 0.25. So if I subtract 1/4 of an inch from my total material thickness, that's going to give me a letter height of just about 1 1/4 inches, which is what the plans are calling for on this letter. So that is the setting, and that's really all you need to do a prismatic letter. Now I can see here there's one area of this B I'm not really thrilled about. I'm using a 1/4 inch end mill, and obviously I can't get in here to create this V in this part. So that would have to most likely be done by hand with a small saw or something. I could take the profile and I could go down to, let's just use an 1/8 inch bit just to show what the look is going to be, and I can calculate that. And you can see that's going to bring me in a little closer, so I could clean it up. The problem is I don't have an 1/8 inch bit that has an 1.5 inch flute length on it. So I'm kind of limited to a 1/4 inch on that. And you know, that's really just the best I can do for that. So we're going to go back and set this back to a 1/4 inch compression. Doesn't really matter which bit. I'll change this when I'm at the machine. Now, the other thing that we're doing here is we want to determine, sometimes, depending on the application that you're doing, you may not always care necessarily about the overall height of the letter, but you may care about this straight wall right here. This is how much vertical you have before the prism starts. So again, I can do the same thing. I could just move my pointer over to the top of that wall, and looking down here, I can see that I've removed about 0.55 inches of material. So being that this was 1.5 inches, that means I'm going to have roughly a 1-inch sidewall on there. And if that's what I want, that's great. If I want a lower sidewall, then I have to kind of figure out, what do I want more? Do I want the letter to have a certain overall thickness, or do I want the sidewall to be, because if I go ahead and I go into Prism Carve, and let's just say I change this to 1.25 inches and go ahead and calculate that and preview it, that is going to remove a lot more material. And, you know, hopefully if I was really doing that, I wouldn't be using 1.5 inch material, because I have to remove so much of it. It seems like a waste. I would just buy thinner material to do that. But the end result here is that, sorry, the preview on this takes a little while. The end result is my letter right now is 0.96, so I've removed about an inch. So that gives me a 1/2 inch from the bottom to the high point. That's roughly how thick these letters are going to be. And from the vertical wall, if I move, it's 1.25. So that gives me a vertical wall thickness of a 1/4 inch. So just by changing that prism depth, I can get a completely different look to my letter. I can make it, you know, a lot thinner. Now, just keep in mind, we've removed an awful lot of material there to get to that, because I'm using an 1.5 inch thick material. On this particular job, you know, I leaving it 140 with a 0.55 prism depth gives me exactly what I need according to what this project is calling for in terms of the overall height and the wall height for the machine. Now, I can also go ahead and change the V-bit that I'm using to get a completely different look. So right now I'm using 140 degree, which is a pretty shallow rise to this prism. If I were to go ahead and redo this, let's just say we select a 90 degree V-bit and go ahead and calculate that. Current tool will need a minimum prism depth of 0.8. So that's telling you right away that I've got to set so I'm going to set for full prism. It automatically knows that I've got to go 0.8475. I'm going to calculate that, reset my preview all toolpaths one more time. And now you see it's doing it in multiple passes. So it's not trying to take this 90 degree V-bit and do it in one pass. It's going to step down. And the other reason for that is my V-bit is not super wide. So the width of my bit is not big enough to do this entire V in one pass. So it's letting me do it in stages. But you can see now I have a total height of the letter at 0.03919. So I've removed a little less, about a 32nd of an inch. So this letter has an overall height of roughly 1.5 inches. So the overall height is still close to the material thickness. And then my wall height over here is 0.82. So roughly 1 1/8 inches is the overall height of the straight wall. So I go from 1 1/8 inches to 1.5 inches, and there's my 90 degree bevel. So, you know, if that's what you're looking for, you can certainly get kind of a deeper prism effect by changing the angle of the bit you have. Now I can also go back. Another common one I use is 120 degree. I can calculate that. Actually, I'm going to do that one more time, but I'm going to do reset the depth and reset the preview and preview everything. So now you can see I've got, this is with 120 degree, and my wall height is roughly 1 inch, and my peak is pretty close to full height on this. So we've only really lost about a 32nd of an inch in height. So again, if I wanted to use, if I like this particular angle, I can do that. I would just have to change the prism height depth here. I'd have to change that so that I can get the overall 1.25 inches that I'm looking for. So you have the option, depending on which bit you have, depending on what machine you have too. Not every CNC machine can spin a 3-inch diameter 140 degree V-bit. The bit I have is from a Mana tool. It's got a 1/2 inch shank. I'm going to be doing this on a larger machine. But if I had a desktop machine that only had a 1/4 inch shank, you have to look and see what they have available for V-bit angles. You may be able to get a 140 degree bit, but you won't be able to run it as aggressively. So you have to really watch your feeds and speeds that you have set up, and talk to the manufacturer to make sure, based on the amount of power your spindle has, how many passes you have to do, and you know, what kind of RPM settings you need, and things like that to make sure you get this right. So that is how you do prismatic letter. I think they're really cool. I've seen them finished a lot of different ways. I've seen them even done in gold leaf. That's kind of neat on the top, and with a contrasting color on the vertical wall. So you have a lot of options there. But if you're looking to do kind of a individual letter signs, and you want something that looks unique, then I would check out the prismatic letter. So I'm going to run some footage and show you what it looks like as it's cutting on the machine.